Hello and welcome to part 2 video of chapter 2 polynomials. In the previous video we have discussed how to find the zero of a linear polynomial. But why is it important to learn about zeros? To understand that, let's look at the geometric meaning of the zero of a polynomial. First, for linear polynomials. What is the general formula for a linear polynomial? Ax plus b. And how do you find the zero of it? Minus b by a, right? Let's take an example. P of x is equal to 2x plus 3. Now let's plot this polynomial on a graph. For that, you have to take different x values and find the corresponding y values, right? So suppose if x is equal to 0, what is the y value? 2 into 0 plus 3, which is 3. You have to replace x by the 0. Now, when y is equal to 0, what is the x value? Y is equal to 0 means 2x plus 3 is equal to 0. 2x is equal to minus 3 and x is equal to minus 3 by 2, right? So, x value is minus 3 by 2. Now, when x is equal to 1, what is the y value? 2 into 1 plus 3, which is 5. When x is equal to minus 1, what is the y value? 2 into minus 1 plus 3, which is minus 2 plus 3, which is 1. Now, when x is equal to 2, what is the y value? 2 into 2 plus 3, which is 7. So, you have found the different x and y values. Now, you have to plot these points on the graph. This is how the graph looks like. A straight line which intersect the x-axis at one point, that is minus 3 by 2, 0. Now, from our equation, what is the zero of the polynomial? Minus b by a, which is equal to minus 3 by 2. Now, if you observe the graph, you can find that it is the x-coordinate of the point where the line intersects the x-axis, right? Minus 3 by 2, minus 3 by 2, 0. So, you can say that the linear polynomial, the graph of a linear polynomial will be a straight line and it will intersect the x-axis at one point, and the coordinate of that point, the x coordinate that point will be the zero of the polynomial. Is it clear? So, the graph of a linear polynomial will always be a straight line and it passes the x-axis at one point, and the x-coordinate of that point will be same as the zero of the polynomial. Now, let's look at the same for a quadratic polynomial. For example, the polynomial x square minus 3x minus 4. In order to plot this on the graph, you have to take different x values and find the corresponding y values and plot them on the graph. And the graph would look like this. This shape is known as a parabola. So, the graph of any quadratic polynomial will be a parabola, and depending upon whether the coefficient of x square is positive or negative, that is a greater than 0 or a less than 0, the shape will be either opened upwards or downwards. We'll have a upward parabola or a downward parabola. Now, can you find the zero of this polynomial without actually solving it? Yes, how? From the table, it is seen that when x is equal to minus 1, y is 0. And when x is equal to 4, y is 0. This is exactly the definition of a zero of a polynomial. That is, if you replace the value of x by any number and you get the final answer as 0, that will be the zero of the polynomial. So minus 1 and 4 are the zeros of the polynomial. Right? And now if you observe the graph, you can find that this is exactly the points where the parabola intersect the x-axis, minus 1, 0 and 4, 0. So you can conclude that for any quadratic polynomial, the graph of the polynomial will be of the shape parabola and it will intersect the x-axis at 2 points. In fact, at most 2 points. That means there are different types of parabolas that can occur and I will show you all of them. Now, intersect the x-axis at 2 points, meaning the quadratic polynomial can have at most 2 zeros. And the coordinates of x at that point will be same as the 0. Right? Zeros of the polynomial. Is it clear? Now let's look at the different types of parabolas that can happen. Case 1. Here the parabola intersects the x-axis at 2 points, right? A, 0 and A prime, 0. In this case also it intersects at 2 different points. That means this polynomial will have 2 distinct zeros. 2 distinct zeros. This is the case 1. Now, let's look at the case 2. In this case, the parabola intersects x-axis only at 1 point, right? A, 0. That means here also only at 1 point. That means the 2 points have become 1. That means they will have 2 same zeros or just 1 0, right? 2 same zeros mean it is just one value, right? Now, what about the case 3? Here, the parabola doesn't intersect the x-axis at all. That means there is no 0 for this 2 polynomials. So, we can say that for any quadratic polynomial, the shape is parabola. We have said that before. And it will intersect the x-axis either at 2 distinct points or 1 point or no point at all, meaning the quadratic polynomial can have at most 2 zeros. Now let's look at the cubic polynomial. For example, p of x is equal to x cubed minus 4x. If you find the different values and plot them on the graph, it will look like this. And you can see that the graph intersects the x-axis at 3 points, right? Which is minus 2, 0, 0, 0 and 2, 0. So from the graph, you can see that these 3 are exactly the zeros of the polynomial. That is minus 2, 0 and 2 are the zeros of the polynomial. Just like how you have seen in the case of a quadratic polynomial, for cubic polynomials also you can prove that there is at most 3 zeros. 3 distinct zeros, okay? In general, you can say that any given polynomial of degree n, the graph of the polynomial y is equal to px will intersect the x-axis at n number of points. That means the polynomial will have n zeros. Now let's look at the exercise questions. Exercise 2.1, question number 1. The graphs of y is equal to p of x are given below for some polynomials p of x. Find the number of zeros of p of x in each case. Question number 1. In this graph, you see that it doesn't intersect the x-axis at all. So it has no zeros. What you have to look for is only the point where the graph intersects the x-axis, not the y-axis. Now, question number 2. Here in this graph, it intersects at 1 point. So, it will have 1 0. Question number 3. Here, the graph intersects at 3 points, right? So it will have 3 distinct zeros. Question number 6, it intersects at 1, 2 and 3 different points. It will have 3 zeros. Our next topic is the relationship between the zeros and coefficients of a polynomial, and it will be discussed in the part 3 video. If you have found this video beneficial, do not forget to like, share and subscribe to our channel, and keep watching our channel for more videos. Thank you.